So atoms in and of themselves are not very stable in their free state. It's very difficult to go and just find a chunk of magnesium or a chunk of lithium or a chunk of gold or iron or whatever just hanging out in the ground. And so what ends up happening is that atoms tend to join or bond to other atoms in order to stabilize. Now, we'll talk more about what it means in terms of stabilization and how that works here in just a moment. But for most atoms, the way in which they bond is going to be dependent upon the number of outermost or valence electrons that are found in their structure. We talked a little bit previously about the octet rule, that is, that most elements want to have 8 electrons in their outermost shell, and so there's really two primary ways that that is done. Either one atom donates its electrons to another in order for both to achieve 8, or they end up sharing pairs of electrons in order to achieve 8 valence electrons. So those two types of compounds that are going to be discussed based off of their ability to bond. And the first is an ionic compound. Ionic compounds have very, very high melting points, anywhere between 500 degrees Celsius to 2000 degrees Celsius and even higher. So they typically tend to be solids at room temperature. In addition to that, they are good conductors of electricity when they are in a liquid state or dissolved in water. However, they are not good conductors of electricity as a solid. And typically you'll find that ionic compounds are metals plus nonmetals. So notice the examples down below. You have Na and Cl. Na, sodium, is a metal and chlorine is a nonmetal. Calcium is a metal, chlorine is a nonmetal. Calcium is a metal, oxygen is a nonmetal. And notice the structure on the right-hand side. They form what are called crystalline structures. You notice that it's very much crystallized, it's very organized, it's very patterned. And you see this in things like table salt and rock salt and things like that. You see this pattern, and that's due to the fact that those materials exist in regards to ionic bonding principles. Now, ionic compounds do not have molecules as a structural unit. What you end up seeing is repeating positive and negative ions that are attached to each other. One of the most fundamental concepts related to chemistry and understanding how chemical compounds work, and even breaking it down even further into the fundamental concepts of protons, neutrons, and electrons, is this idea of Coulomb's law. And Coulomb's law is something that you're probably already aware of. You just may not be aware that you know it. It's the concept that opposite charges attract one another. That is, something that is positively charged is going to be attracted to something that is negatively charged. Similar charges will repel one another, and opposite charges will attract one another. The magnitude or the size of the charges determines the strength of the charge as well. So, for example, if I have two really strong magnets that are oppositely charged, they're going to be more attracted to each other than two magnets that are relatively weak to each other. You'll see more on this here in just a moment. But the formula, the chemical formula for this that we're going to take a look at here in just a little bit, is the lowest whole number ratio of atoms within the compound. So you notice the structure here has hundreds of positive and negative ions. But notice that they all relate to each other in a 1-to-1 ratio. So when we describe the compound in a chemical formula, the number of atoms are going to be in a 1-to-1 ratio. And again, you'll see that when we do our nomenclature work here in just a little bit. Now, molecular compounds are a little bit different. They have relatively low melting points. They tend to be poor conductors of electricity and are typically a gas or liquid at room temperature. These are typically all non-metal compounds, these all contain non-metal elements. So these are things to the right-hand side of the stair step. So things like CO2, H2O, SF6. These are all things that have low melting points. They don't conduct electricity well and are typically a solid or gas at room temperature. We'll discuss more on molecular compounds in a later unit. Now, one of the key ways that we differentiate between the two different categories of compounds is because they chemically bond in two completely different ways. Ionic substances contain ionic bonds, and these are attractive forces due to the transfer of electrons from one atom to another. An ionic compound is one which contains ionic bonds, so you notice that you have two atoms that are on the right-hand side. You have one atom that is a metal that has one electron in its outermost shell, and you have atom 2, which has 7 electrons in its outermost shell. So atom number 1 is going to donate its outermost electron to atom number 2, thus resulting in both having 8 electrons in their outer shell. We'll discuss that in a moment. But the idea here is that if A loses an electron, it drops a negative charge. And if it drops a negative charge, remember that neutral atoms have the same number of positive and negative charges associated with them. So if I lose a negatively charged particle, that all of a sudden makes the atom positively charged. And because B gains an electron, it increases its negative charge, thus making it negative. And so we have a positive ion next to a negative ion. Opposite charges attract due to Coulomb's law, and you all of a sudden have something that chemically bonds with each other. Molecular compounds do something a little bit different. They contain covalent bonds. Covalent bonds are a type of attraction involving the sharing of two or more electrons. Now, we won't get into too much detail here, but if I do look at the example on the right-hand side, we have two atoms each with 7 valence electrons. So donating 1 electron to another is not going to allow each to have 8. However, if they each share 1 electron with each other, all of a sudden they now have 8 valence electrons in their outermost shells and therefore are chemically bonded together. They're going to be very stable. We're going to discuss these a little bit later in a more detailed discussion in unit number 5, but I do want you to keep in mind that no bond is truly 100% covalent or ionic. We typically put these two things into buckets because it's much easier for students to comprehend and for people to understand. There really is more of a continuum in regards to whether something is ionically bonded, covalently bonded, etc. It's a discussion for a later day, but it does make it easier for us to categorize bonding. That way we can describe it in a little more detail and provide just a little more categorization. As humans, we like to categorize things into buckets. It just makes it easier for us to comprehend that information. So take a few moments, think about what we've discussed here, and think about electron transfer versus electron sharing. Is that ionic? Is that covalent? And then provide 3 characteristics for an ionic compound and 3 characteristics for a covalent one. We'll be back and finish up this discussion here in just a moment. All right, so if we're looking at electron transfer, that is ionic bonding, and electron sharing is covalent bonding. Simple enough, we just discussed that. 3 characteristics of an ionic compound versus 3 characteristics of a covalent compound. There's a lot of things that you could put forth here, but ionic compounds are solid at room temperature. They have high melting points and can conduct electricity when a liquid or in solution. Covalent compounds have low melting points, cannot conduct electricity, and are a liquid or gas at room temperature. There's a variety of other physical and chemical characteristics that we can use to describe things that are ionically or covalently bonded, but these are the primary ones that I want you to be able to know.